Good morning, my dear student. Today, let us let us discuss about that the Cantor set has got a Lebesgue measure 0. So, in the last class, we have discussed that every non-empty perfect subset of R is uncountable. So, Cantor set being a non-empty perfect subset of R, Cantor set is also uncountable. So if we are able to show that Cantor set has got Lebesgue measure 0, then we are able to give an example that there exists an uncountable set whose Lebesgue measure is equal to 0. Okay, so Cantor subset of 0, 1 closed interval is given by, how we last time we have already discussed. So this is Cantor set P. Let us call P is the Cantor set. Okay, so this is equal to how much? So this is equal to intersection n going from 1 to infinity Pn. Okay, where Pn is equal to k running from 1 to 2 to the power n jnk. All right, so let us briefly recall how we construct Cantor set so that you will understand properly. First, let me open the fan window. There I want to draw something. Yeah, Cantor set. So how we construct Cantor set, let us talk about briefly. So first we consider this 0, 1 closed interval. This is 1 and this is 0. So this is 0, 1 closed interval. Okay, this we divide into 3 equal part. Okay, then each part has got length 1 by 3. All right, so this is the middle third part. This we call it I11. We call it I11, and this is middle third is open interval. The remaining two part, this we call it J11, and this we call it J12. So J11 and J12, they are closed interval, and the middle third part, this is I11, this is open interval. Okay, so each part has got same length. What is the length? The total length is 1 by total length is 1, therefore each part has got 1 by 3. This is length 1 by 3, this is also length 1 by 3, and this is also length 1 by 3. Okay, this is open interval, this is closed interval, this is closed interval, this is also closed interval. Then we call P1. P1 is what? P1 means first step. P1 is equal to J11 union J12. So this is we call P11, and I is what? I1 is equal to I11. So what we understand is that this has 1 by 3 length, this also has 1 by 3, this is also 1 by 3. So 1 here signifies the first step, and this is second step. So I here, this is also first step. Okay, and the second step again from the after removing this closed interval. Okay, after removing this closed open interval, let us discuss about the remaining closed interval J11 and J12, and this is length 1 by 3, and this is also length 1 by 3. This again we divide into 3 equal part. Okay, the middle one is here also open interval, this is closed interval, this is closed interval. So this is total length how much? 1 by 3. If you divide this is into 3 equal part, each of part will have length 1 by 3 square, that is 1 by 9. Okay, let us call this part as J21. This part is J21. Let us call it J22. Okay, and this middle third open interval, let us call it I21. All right, so this is also length has it has also length 1 by 3 square. Okay, all of them has same length. From here also you divide into three equal part. Okay, the middle third part is here. Middle third part is here. This is open interval, and this we call it I22, open interval I22, and the remaining this one is J23. Okay, and this one is J24. So how many closed interval are here? 1 2 3 4, 2 to the power 2, 4 closed interval are here. How many open interval do you remove? There are two open interval, I21 and I22. So in the second step your P2 is what? In the second step your P2 is equal to, how many open intervals closed intervals are there? 4 closed intervals. So you take K running from 1 to 2 to the power 2 is 4, and name of the interval you remove is J2K. So this is your P2. Okay, this is your P2, not remove. This is the remaining closed interval. It is disjoint union of 4 closed interval. Okay, and how many interval you remove? In the second step you remove 2 open interval. In the second step 2, how many open interval? This one and this one. So this is equal to union how many? 2. Let us, R is running from 1 to 2 to the power 1 is 2, 2 to the power 2 minus 1 is 2, 1. So 2 interval I in the second step 2 R. So in the second step, okay, in each step length of this J2K is equal to length of this I2R. Each of length how many? 1 by 3 square. Okay, 1 by 3 square here also. So then again you further divide in the third step, after removing this one, in the third step remaining closed interval, this one, this one, this one, this one, again you divide into 3 equal part here. Okay, so and then the middle third open interval you remove, like that. So in that way, how much intervals are there? In that way your P3 will be how much? P3 will be how much? It is disjoint union of K running from 1 power to the power 3. 8 intervals are there, and the name of each interval is what? J3K. All right. So similarly, what is the remove? What is the remove interval? I3. I3 is equal to how much? I3 is equal to how much? Here R is running from 1 to the power 2 to the power 3 minus 1, and name of the remove interval, open interval, is what? I3R. Okay, so this is the third step. So what is the length of this step? What is the length of this interval? J3K. Okay, how many intervals are there? 2 to the power 3, 8 intervals are there. Each of length how much? 2 to the power 3, means 1 by 27. This one also, what is the length? 2 to the power 1 divided by 3 to the power 3, that is 1 by 27 length. Okay, so then how many interval are here? How many interval? 2 to the power 8, 2 to the power 3, that is 8 interval, disjoint intervals are there. So then total length is how much then? Total length means measure P3 is how much? Measure P3 is how much? So each interval has got 1 by 27. How many such intervals are there? 8 interval, means 2 to the power 3 divided by 3 to the power 3. This is the length of the interval P3. Okay, so similarly here, so how many intervals are there? Open intervals are there. There are 2 to the power 3 minus 1, means 4 intervals are there. Each interval has length 1 by 3 cube, that is 1 by 27. So measure of I3 is how much? Measure of I3 is equal to how much? 4 to the power 2, that is 3 minus 1 is 2 divided by 3 to the power 3. This is the length of the interval in the third step. Similarly, in the nth step, what is your Pn? In the nth step, what is your Pn? Pn is equal to the remaining closed intervals. Now this is union, okay, union k running from how much? K running from 1 to the power n, and the name of the interval is what? J n k. Okay, so length of each interval is how much? 1 by 3 to the power n. Okay, so how about the in? In, the remove open interval. Total number of interval is how much? R running from 1 to the power n minus 1. Name of the interval are in r. Okay, so how many interval here? 2 to the power n minus 1. How many intervals here? 2 to the power n. Each interval has length how much? 1 by 3 to the power n. Here also each interval how much? 1 by 3 to the power n. So total, length is how much? Then measure Pn is equal to how much here? This is equal to total number of interval is 2 to the power n divided by each interval has got 1 by 3 to the power n. So 3 to the power n. This is the length or measure of the interval in the nth step. And similarly, what is measure of in the nth step? The remove interval, the remove open interval. Okay, so this is equal to how much? 2 to the power n minus 1 divided by 3 to the power n. Okay, this step. So after removing in, what you get? You get Pn. So then from the elementary set theory, the complement of in is how much? Complement of in is equal to Pn. All right. Similarly, what is the complement of Pn? Complement of Pn is equal to, after remove Pn, you will get I. Complement of Pn is equal to how much? In. These are the basic thing. These are the basic thing of the Cantor set we construct. Okay, then this step you keep on going this step up to how many times? Up to infinitely many times. Okay, in each step you will get P1, P2, P3, P4 like this. All this one. So from the construction again, P1 is a superset of P2, P2 is a superset of P3, P3 is a superset of P4 like this on. So you have a sequence of decreasing closed interval. Okay, so by Cantor intersection theorem, their intersection is non-empty, their intersection is also closed. That intersection, infinitely many intersection, we call it Cantor set. Okay, so this is the background, this is the thing we discussed earlier. I just remind you for this one. Okay, so for your understanding, then the P is equal to how much? P is equal to, P is equal to this intersection n going from 1 to infinity Pn. Okay, so where Pn is the disjoint union of, I just explained you now, disjoint union of 2 to the power n closed interval. Okay, J and K. All right, so measure of J and K is 1 by 3 to the power n, and then total measure of Pn is equal to 2 to the power n, 3 to the power n. Okay, also In, the remove interval in the nth step is how much? 2 to the power n minus 1 disjoint open intervals are there. So total union is R running from 1 to 2 to the power n minus 1 in R. Okay, so each interval has got measure 1 by 3 to the power n. Therefore measure of the in is equal to 2 to the power n minus 1 3 divided by 3 to the power n. Okay, so again I told you, complement of Pn is equal to In. Complement of Pn is equal to In. Okay, complement of Pn is equal to In is equal to, what is In? In is union of 2 to the power n minus 1 disjoint open interval INR. Okay, then let us define complement of Cantor set P. Complement of Cantor set P is equal to, complement means difference between 0, 1 closed interval and P, set difference, not minus. Okay, so this is equal to 0, 1 into what is P? P is intersection n going from 1 to infinity Pn. So by De Morgan's law, this is equal to union n going from 1 to infinity, Pn complement. Okay, Pn complement means what? R running from 1 to the power n minus 1 I n r. Okay, so therefore ultimately your P star is equal to union running from 1 to infinity, union running from R, okay, 1 to the power n minus 1 I n r, a disjoint union. This is, from the construction it was obvious that is open interval, I mean they are pairwise disjoint, a disjoint union of open interval. Okay, so therefore by the definition of measure, their measure is sum, measure of P star is equal to sum of the length of the disjoint intervals. Okay, so this part has how much? This part has how much? 2 to the power n minus 1 divided by 3 to the power n length. So therefore this is summation from this summation, what? N running from 1 to infinity, this much. So from geometric series, this is equal to first term divided by common ratio, the 1 minus common ratio, this is equal to 1. So that means what? Measure of P star is equal to 1. Okay, measure of P star is equal to 1. Therefore, since P is a subset of 0 1, this is set difference. Okay, this is set difference. P is a subset of 0 1. So what is a measure of this set difference? This set is equal to measure of 0 1 minus measure of P. So this is minus and this is difference. Okay, so this is from the theory we have discussed last time. So measure of 0 1, measure of P, and this has got measure 1. 1 is equal to 1 minus measure of P. So after cancellation, measure of P is equal to 0. That means measure of Cantor set is equal to 0. Okay, so now we are able to show that measure of Cantor set is equal to 0. But Cantor set being an uncountable set, we are able to find an example of an uncountable set whose measure is equal to 0. So hence shown. So this is the goal of our tutorial, last and this one also, I mean this one completely. Now we are able to show that there the existence of an uncountable set whose Lebesgue measure is equal to 0.